You've probably heard that black holes suck everything in like a cosmic vacuum cleaner, but that's not really how they work, and the real story is way more interesting. A black hole isn't actually a hole, it's an object, an incredibly dense point in space where gravity is so strong that nothing can escape it. Not gas, not dust, not even light. And when light can't escape, you can't see it. That's why we call it black. But how does something like that even form? It starts with a star. Not just any star. We're talking about a star that's at least 20 times bigger than our sun. For millions of years, that star burns by fusing hydrogen into helium in its core. That fusion creates an outward pressure that balances gravity. It's basically a constant tug of war, gravity pulling in, fusion pushing out. But eventually, the star runs out of fuel. Fusion stops. And when fusion stops, gravity wins. The entire star collapses inward in a fraction of a second, and that collapse releases so much energy that the outer layers explode in what's called a supernova, one of the most powerful events in the universe. What's left in the center is a core so compressed, so unimaginably dense, that it becomes a black hole. Now here's where it gets weird. Around every black hole, there's something called the event horizon. Think of it as the point of no return. Cross that line, and you're not coming back, ever. Not because something grabs you, but because to escape, you'd need to travel faster than light, and nothing does that. But outside the event horizon, you're actually fine. If our sun somehow turned into a black hole right now, same mass, just compressed, Earth wouldn't get sucked in. We'd just lose our light and heat. The gravity at our distance would be exactly the same as it is today. Black holes don't hunt, they just sit there. You have to get very, very close before things go wrong. And when you do get close, things get strange in ways that sound like science fiction but are completely real. Time slows down. The closer you get to a black hole, the slower time moves for you compared to someone watching from far away. This isn't a theory. It's been measured here on Earth using extremely precise clocks at different altitudes. Gravity literally bends time. And if you were falling into a black hole feet first, the gravity pulling on your feet would be so much stronger than the gravity pulling on your head that your body would stretch out like spaghetti. Scientists actually call this spaghettification. That's a real term. Now, can we see black holes if light can't escape them? Yes, actually. In 2019, humanity got its first real image of a black hole. It was captured by a network of telescopes working together called the Event Horizon Telescope. What we saw was a glowing ring of superheated gas swirling around the black hole, with a dark shadow in the center. That shadow is the event horizon. The black hole in that image is called M87. It sits 55 million light-years away, and it's about 6.5 billion times the mass of our sun. Let that sink in. 6.5 billion suns collapsed into a single point. There are black holes at the center of almost every large galaxy in the universe, including our own. The one at the center of the Milky Way is called Sagittarius A star. It's about 4 million times the mass of the sun, and it's sitting roughly 26,000 light-years away from us right now. Safe distance. For now. Black holes are still one of the least understood things in physics. We don't know what happens inside them. We don't know if the information of everything they consume is truly lost forever. Some of the smartest people alive are still arguing about this. What we do know is that they're real, they're everywhere, and the universe is a much stranger place because of them.